Hi guys, welcome back to my channel. Let's do move zeros. So we're given an integer array called nums, and they want us to move all zeros to the end of it while maintaining the relative order of the non-zero elements. So they say note that you must do this in place without making a copy of the array. So if we take a look at example 1, we're given this input array nums equals this, and output would be this. So basically we're just taking all of the non-zero elements to the front and moving all of the zeros to the back of the array, and we do this while maintaining the order that the numbers were given to us in, other than the zeros obviously. In example 2, we're given this input array and we would return this output because there's only one element in here, which is the 0, so there's not really anything to change here. So in this problem, what we can do, so you can do this like several ways, but what we can do here is first move all of the non-zero elements to the front, and then once we do that, if we keep track of like how many elements we moved, then that we know, like, so we know to start from there, we can just make the rest of the array zeros because we don't need to keep track of anything really to do that. So like for example, given this, we can first move all of the non-zeros to the front. So if we start with this, if we just rewrite this, so 1, 3, 12, right? And then we keep track of what index we are at here, then from the rest of it we can just fill this up with zeros, like that. So that's basically all I'm going to do. So we're going to start with a pointer to keep track of what index we're going to be inserting our non-zeros into. So we'll say insert position, and we'll start it at 0, and then we're going to do a for loop, to move all of the non-zeros to the front of the array. So for num in nums, and then if num is not 0, then we can move it to the array at whatever index our insert position is at. So then we can say nums at insert position is num, and then we're going to increment our insert position. Okay, and that is because, so like in our first pass here, so insert position 0, num is going to be 0, because it's this first element, and then so since it is 0, we don't do any of this, and then we just go to another iteration of the loop. Then num is going to be 1, which is not 0, so then num's at insert position, which is 0, is going to be equal to num, which is 1, like that. Let me actually not write over that. I'll just reuse this one. So okay, then this will become a 1, and then insert position will increment, so that will be 1. Then the next iteration, num will be 0, so since this is 0, we don't do anything here, and then we just continue. So then num will be 3, and insert position was 1, so since 3 is not equal to 0, then we will make this into 3, and then insert position will increment. And then next round, num is 12. 12 is not 0, so insert position at 2. So num's at insert position, which is 2, will equal num, which is 12. 12, and then insert position will increment to 3. So now we have looped through all of nums. So we exit this loop, and then now basically we have moved all of the non-zeros to the front, and so we just need to fill in the rest of this with zeros. And so we can just do that with a quick while loop. So while insert position is less than nums.length, then we can just fill in the rest of it with zeros. So nums at insert position equals 0. And keep in mind, we left off with insert position at 3, which is exactly the index that we want to start at when filling out the rest of the arrays with zeros. So that works perfectly for us. So then we can just increment insert position, and that should be it. So insert position will start at 3, so then nums at insert position, we'll set that equal to 0, and then plus plus, so now this will be 4. Then this is still less than nums.length, so then nums at insert position, we set this equal to 0, and then plus plus, now it equals 5, and then now it's no longer less than nums.length, so we exit the while loop, and that is it. So let's run that. Okay, so our time complexity is going to be O of n, where n is the number of elements in nums. And that's because we're just looping through this array basically relative to n. Like we just visit every element one time in total, because we go through part of it for this for loop, and then we go through the rest of it in the while loop, but like if we add these up, it's gonna be O of n. And then our space complexity is just constant because we don't have any additional data structures here. So that's it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. I'll see you guys next time. Bye!